Hi, also today I'd like to talk about my design for YouTube. And yeah, just to get started, here's the functional requirements. Just some background, I guess. YouTube is just a video streaming service slash website which allows you to stream videos, upload videos, search videos, and add likes and comments. So these are the 5 features that I'm going to be covering in my design for YouTube. In addition, some of the non-functional requirements include high availability, scalability, good performance, and reliability. So yeah, let's get started. So the first thing that I think about when I design any system is where is the data actually going to reside, and where can we place points where we actually read and access this data for the best performance. So immediately the first thing that I think of is actually caching the most important or most recently loaded videos and app data locally on the client devices itself. So this way the user has the best experience, such that if he closes a video and decides to reopen it, or it's something in his recent history and it's not exceeding like a certain size limit which is imposed by the operating system on the client's device, then that cached app data will lead to the best and smoothest access to the data. The second point is, in order to allow for the fastest access of the data, especially for a system that scales out as much as YouTube, it makes sense to actually use systems such as a content delivery network to actually store our data in strategic geolocations. That way, when this is kind of around the assumption that once a user is within an area of a specific geocenter, they're not going to move around that much. So that way, when we actually store the users, store what videos have been accessed around that specific geolocation, it'll allow for quick retrieval. That way, videos that are trending in a certain area or in a certain language can be accessed and retrieved very efficiently. So to summarize that, I would have a content delivery network that actually stores videos which are actually trending and frequently accessed in the area around the globe. And there would be a central server somewhere, which a kind of bigger central server somewhere that actually stores additional or maybe even all of the videos for YouTube. But if we want to essentially allow for modifications of sponsored content or things or deliver updates to clients for the app, this can be pushed out from the central server to points in the content delivery network, which can further be delivered to client devices. So yeah. Now, just to get into the specifics of how we're actually going to store the data and what's going to be stored for allowing for this functionality, we would use a blob store. This is just a binary large object store that's just used for storing things like video, and can also store for each video what are the number of likes, the number of comments, the number of subscribers, and other information like this. In addition, we can also include tags, which we can get like based on the description of the video, what the comments are saying, and maybe in the future, well, not in this design, but if we were to transcribe what the person is saying in the video, we could actually process that to get what type of content is being stored, and this would be useful for the search service. So now, just to get into the guts of it, now that we know exactly where our data is stored. So of course the client will need to talk to the server in some way, and the way that I would do this is via a gateway. So the gateway, we can use either TCP or HTTP/HTTPS. And in this case, because in YouTube there's no real reason for YouTube to actually send notifications to the device, although if we were to extend the functionality to something like push notifications that a user can configure later, then it might make sense to use things like TCP. But for the YouTube in this specific design, it would make sense to use HTTPS. So now onto a typical workflow for the first point of functionality, which is to stream and upload videos. So the way this is done is that a device can send messages to the server, and this will be parsed to see what type of request there is. And the way this would work is, so I can just add something here. Yeah, so over here, the device would send like a type of message such as stream, search, upload, comment, like. So the user can send messages like this to the server, and it would go through a gateway which would pass this to a parser. So just going through some details into the gateway. The reason that I separated a gateway as a separate microservice is this is basically the first interaction that the client sees, and this will be responsible for actually handling any requests that are sent by the client. And we want this to be as lightweight as possible to not process extra things. And we can add protection on the gateway by using things like a reverse proxy that will shield the internal servers from IPs from being exposed. And in addition to security, the gateway also can allow for a simpler means of communication within the network. Because when we're communicating via HTTP, it carries some extra information on the headers and those things which may not be required internally within the YouTube service. So we don't need we can abstract and save us some internal overhead by using a gateway, which is the only thing that actually communicates via an HTTP protocol. In addition, in order to allow for easier scaling out on all of these services, we can use things such as consistent hashing for load balancing. In addition to, this is a method for kind of distributing the workload amongst like servers in the gateway or in any microservice that exists within the architecture. So now just moving on to a typical workflow, what would happen is, let's say the client sends a upload request. So this would send an upload along with the video content to the gateway, and this would be the message. This would just be forwarded to the parser if this is a valid request and none of the packets got dropped. And the parser would see that this is an upload, and it would send this to the storage service. The storage service is essentially in charge of just managing interactions with the database, and it sees that it's an upload request, so it processes a write to the blob store, creates a new URL for the video, and stores it. On success, it can return a success token back to the client. Similarly, for search or stream, then, or I guess I can start with stream first, then we can move on to search. For a stream request, when we start playing a video, as I mentioned before, if this is a video which is popular in the area or something the user has already downloaded or accessed before, this data would already be available on the client device. And if it was trending in the area, then it would be inside the endpoint of the content delivery network. It would be inside the blob store for that specific content delivery network. And that's where the data would reside. But just to get into the specifics of how it's received, once you hit play on the video, it would go to the gateway, and the parser would see that it's actually a streaming request. It would go fetch the data from the storage service, and the storage service, once the lookup once the lookup is done, would pass it back. So the key that we would actually pass to the storage service would be the URL for the video. And the URL for the video can be used for lookup into the blob store. It'll fetch the content and then stream the data back to the device. Yeah, so now onto the search service. As I mentioned before, when a video is uploaded, we can extract features from it using the title and the description. So without introducing an additional service that does transcription and maybe some preliminary machine learning analysis to kind of determine what type of content the video is, it would just look at the title and the comments and just use that to actually say it's inside a specific, it's a specific type of content. So when the user searches for something, we can, the request is sent to the parser, which sends it to the search service. Now the search service here, this is another microservice that actually uses, which constructs like the related, which can gather like the related words and related topics for that specific search request and send that to the storage service for lookup. So the storage service here, I guess it processes a different type of request than before, which is just lookup by the URL, but it can do a lookup by features and actually return a batch of like recommended videos, and this would go back to the parser. The parser is kind of the central point that gathers the results from the storage service and passes that back to the device. So that is how searching would work. Yeah, so next is, so likes and comments would also work similarly. As I mentioned before, we can, inside the blob store, there'll be the video itself, the URL, the title, the description, and the likes and comments. So this data is just, so when a like or comment is seen by the parser, once the client device actually sends it, it will send it to the storage service, which will just update a comment being added to this video at this URL, and this comment on the video is being liked or replied to, etc. So that's how liking and commenting would work. In terms of other details such as what type of database and which pillars in the CAP theorem I would use for this service, I would use a NoSQL database in this case. So the reason for that is, as I mentioned before, it makes sense to me to use to actually allow for a content delivery network to be there by geolocation. So NoSQL intrinsically supports sharding, and there's specifically a qualifier that's expected by NoSQL databases that allow you to retrieve data from a particular node, and it allows for easier horizontal scaling and for the basically the need for scaling in a service like YouTube, which is used around the world with millions of users a day. It makes a lot of sense to use a NoSQL database, which the whole architecture is built around the fact that this is going to horizontally scale a lot. So that's the type of database that I would use. And in terms of the pillars and CAP theorem, I would make the system more available than consistent, because considering the scale at which it will operate like around the world, you don't want network delays to kind of reach a consensus before you actually push out like a comment. It's okay if someone sees a comment to show up late or a video show up a little bit later in a different part of the world than it is to actually have your service being down for a certain amount of time. So I would use databases such as Apache Cassandra, NoSQL databases such as Apache Cassandra, and yeah. So availability over here trumps consistency. So yeah, I think that's it.